Hello, this is FlippedHarber for Algebra 2. In this video we're going to cover section 5.8, curve fitting with quadratic models. Our objectives for this lesson are to use quadratic functions to model data. We also want to use quadratic models to analyze and predict. The outline for this video will start by identifying quadratic data. How do you know that it's quadratic in nature? And then we'll talk about writing a quadratic function from data. Now, identifying a quadratic data, that is, they give us a table of data and they want to know, is it quadratic? Well, first of all, we want to look for equally spaced x values. So if you'll notice, as we move through this table, these x values all go up by 1. That's great. So now we're going to move along in the y data, and what we're going to look for are equally spaced second differences. Now, this is a little bit deeper than trying to decide if something is linear. If you think way back, the way that we found out if something was linear was we looked at the differences in the y values. We're going to have to dig a little bit deeper, but it starts by finding the differences. So, if we go 4 minus 9, we get negative 5. 1 minus 4, we get negative 3. 0 minus 1, we get negative 1. And we continue on subtracting as we go. Now, I need to find the differences for these numbers. It's what we refer to as the second differences. So negative 3 minus negative 5 is 2. Negative 1 minus negative 3 is also 2. So really what this is saying is that all of these numbers are going up by 2. And it's this here that says, yes, this is quadratic data. This is what we have to look for when we're trying to determine if data is quadratic. Look for an equal second differences. Alright, so the next thing that they're going to ask you to do in your homework is to write a quadratic function that fits points. Now, if they give you a problem like this, you do not have to check and see if it's quadratic. They're saying this data is quadratic, just find the equation for it. So, we're going to need to find the a value, the b value, and the c value for this standard form. So we go ahead and we plug in our x value and set the whole mess equal to the y value. So ax squared becomes a times 0 squared plus b times 0 plus c, and we set it equal to our y value. Now, it was really nice of them to include a 0 comma whatever number, because whenever you see this, this is your c value. So you can see that our c is 5. Now, we do the same thing with our next 2 points. We plug in 2 for x. We set the whole mess equal to 1. Plug in 3 for x. Set it equal to 2. Now, we can go ahead and plug in 5 for our c value since we know it. But what we're going to want to do is go through any process to solve this system of equations. Okay, so let's set it up like that. It's a system of equations that I need to solve for. Now, I've already got c, and that's nice. So let's go ahead and use that. Let's plug 5 in to the bottom 2 equations for c. So now all I have to find are a and b. Well, let's go ahead and do a little bit of reshuffling. So I subtracted 5 over into each of these. And now I need to get either the 4 and the 9 to be the same, or I need to get the 2 and the 3 to be the same. Well, I think it's a whole lot easier to make the 2 and the 3 the same. So I multiplied the top equation by 3. I multiplied the bottom equation by 2. Now that these match, I subtract. solve for my a value, I get a equals 1. I'm almost done. All I need to do is find my b value. Turns out that my b is equal to negative 4. I already knew what my c value is, but now I'm going to put it all together. Remember, a, b, and c are part of a quadratic function. So a is 1, b is negative 4, c is 5. Here's my quadratic function. Okay, that's it. That's all that we really had to cover. How do you determine if data is quadratic? How to find a quadratic function from data. So, time for you to get out that homework and try some on your own. I'll see you in class and I'll see you online.